Okay, hello class. So this is the last video that I will be providing you. And for this video, we will be discussing about the other fixatives which are utilized in the histopathology laboratory. Okay, so in addition to the aldehyde formulations that we have discussed before. Okay, so the next group of fixatives that we can use in the laboratory are referred to as your metallic fixatives. Okay, so when we say metallic fixatives, from the term itself, metallic, it contains a metal. Okay, a metal um, substance as the basic formulation of these different fixatives. All right, so what are the three metals or metallic substances which may be incorporated in our fixatives? So first, we have your mercury chloride-based metallic fixatives. So under your mercury chloride-based metallic fixatives, we have four, okay? And just like what I have mentioned in my previous discussions, how would you know that a particular fixative contains mercury chloride? So of course, you look for the terms zincer, okay, sublimate, and of course, your corrosive, yung mga terms na yon. So you look for those terms and it will give you a clue that a particular fixative contains mercury chloride. All right, so under your mercury chloride metallic fixatives, what are the different formulations? We have your zincers, okay, another is your zincer formol. We also have your Heidenhains. Okay, we also have your Heidenhains, okay, Susa. And then lastly, we have your B5 fixative, all right? So these are the different mercury chloride formulations that we use in the laboratory, okay? So in addition to your mercury chloride fixatives, another metallic based fixative would be your chromate fixatives. So under your chromate fixatives, we also have four, okay, formulations or solutions that you can use for fixation. The first one is your 1 to 2% chromic acid, and then we also have your 3%. Okay, so another one, we have your 3% potassium dichromate. Okay, another is our Regauds. Okay, Regauds fixative, otherwise referred to as your Moller's fixative. And then lastly, under your chromate fixatives is your Orts fixative. Okay, so these are the different fixatives that we can use in the laboratory. These are the different chromate-based fixatives that we can use in the laboratory for the fixation of your tissue samples. Okay, and the last metallic fixative are your lead-based fixatives. Okay, so under your lead fixatives, we only make use of one formulation in the laboratory. And what is that formulation? We have your 4% basic lead acetate. Okay, so your 4% basic lead acetate, this is used for the preservation or the fixation of acid mucopolysaccharides. So I hope you can still remember your acid mucopolysaccharides, okay, from your ano pangalan nito? Human histology. Okay, so again, going back to our knowledge on acid mucopolysaccharides, so remember that this is a kind of tissue that is particularly present. Okay, so this one, it is present in your Wharton's jelly. Okay, so what is your Wharton's jelly again? This is a component of your umbilical cord. Okay, so this is a component that is present in your umbilical cord. Okay, so acid mucopolysaccharides in your Wharton's jelly, which is a component of your umbilical cord. All right, so another, apart from your acid mucopolysaccharides, your 4% basic lead acetate is also utilized for the fixation of connective tissue mucin. Okay, so I repeat, it's also utilized for the fixation of your connective tissue mucins. Okay, so that is the lead fixative that we utilized in the laboratory, as well as the different structures which it preserves. Okay, so we will be sorry, we will be discussing the different specific metallic fixatives. And to start it off, actually we have started it because we have finished your, or we're done discussing your lead fixatives. So the next group of metallic fixatives that we will be discussing is your mercury chloride, or are your mercury chloride based fixatives. Okay, so again, how would you know that a particular solution contains mercury chloride? So you look for the terms zincer, what else? Sublimate, and of course, corrosive. Okay, so those terms, if they are present in the name of your fixative, then it indicates the presence of your mercury chloride. So your mercury chloride fixatives in general, they are considered to be the most common metallic fixatives which are utilized in the laboratory. And apart from that, your mercury chloride fixatives, they are the ones that we use for tissue photography. Why? Because your mercury chloride, okay, so they allow opacity or radio opacity to be produced if you are going to make use of your mercury chloride fixed tissue samples. Okay, so meron kang makikitang radio opacity, okay, which is a characteristic of your mercury chloride based fixatives. That's why one of the applications of your mercury chloride fixatives is that they are utilized for tissue photography. Okay, so apart from that, your mercury chloride based fixatives, they are commonly used or utilized for the fixation of renal biopsies, okay, for your renal biopsies. So one common disadvantage of your mercury chloride-based fixatives is that the tissue may contain black precipitates. Okay, so that is a common disadvantage of your mercury chloride-based fixative. So merong black precipitates yung tissue samples natin. Okay? So, there is an exception to this rule. So, all of them are liable to form black precipitates except in the case of your Heidenhain-Sousa. Okay? So, except your Heidenhain-Sousa. All right? So, let us look into the different mercury chloride-based fixatives. So the first one is your Zenker's fluid. Your Zenker's fluid, this is made up of mercury chloride. Okay, so components of your Zenker's, we have mercury chloride, and glacial, okay, and glacial acetic acid. All right. Yes. So the glacial acetic acid that is incorporated in your Zenker's fluid, this is added before using your Zenker's fluid. So I repeat, your glacial acetic acid, so this is added before using your Zenker's fluid fixative. So the purpose of adding your glacial acetic acid in your Zenker's fluid is to prevent the formation of your precipitates. Okay? So your Zenker's fluid, this is utilized for small pieces of liver, spleen, connective tissue fibers, and your nuclei. Okay? So they are capable of fixing, okay, fixing your connective tissue fibers and your nuclei. Okay, so your Zenker's fluid, this is recommended for trichrome staining. Okay, so I repeat, your Zenker's fluid, this is recommended for your trichrome staining technique. Okay? Yes. So, in instances wherein your Zenker's fluid uh, produces black precipitates in your tissue sample, there is a procedure that we can perform in order to remove the black precipitates which has formed in your tissue samples. And this particular procedure is referred to as your dezenkerization. Okay? So dezenkerization, this is the process of removing black precipitates by using your alcoholic iodine. Okay, so I repeat, by using your alcoholic iodine. So dito ka na lang ilalagay ha. Yes. So the dezenkerization process, okay, dezenkerization process. So this is, or this involves the removal of your black precipitates using alcoholic, okay, using alcoholic iodine. Okay, so in order to prevent these black precipitates from interfering with the examination of your tissue sections later on. Okay, so another formulation of your mercury chloride is your Zenker formol. So take note that your Zenker formol, this is otherwise referred to as your Helis fixative, and this is used in the fixation of pituitary samples, okay, as well as bone marrow samples and other blood-containing organs, okay? So examples of blood-containing organs would include your liver and your spleen. Okay, so ibig sabihin, ginagamit din po siya, just like for your Zenker's fluid, it is also utilized for the preservation or the fixation of your liver and your spleen. Okay, so apart from that, your Zenker formol is utilized in order to fix cytoplasmic granules which may be present in your cells. Okay, so I repeat, your Zenker formol, this is utilized for the fixation of cytoplasmic. Dapat ito. Okay, we have your cytoplasmic granules. Yan, we have your cytoplasmic granules which may be present in your cells. Okay, so those are the different uses of Zenker formol. Okay, and the next one, we have your Heidenhain-Sousa. So Heidenhain-Sousa, this is considered to be an excellent cytologic fixative. Okay, and apart from that, another advantage of your Heidenhain-Sousa as compared to the other mercury chloride-based fixatives is that it does not form any black precipitate. Okay, bakit kaya? Ma'am, bakit kaya? Okay. This is because of the presence of your glacial acetic acid, which is already incorporated in the formulation. So remember, glacial acetic acid in your Zenker's fluid is added in order to prevent, tama ba ako? Okay, in order to prevent the formation of your black precipitates. Okay, so in your Heidenhain-Sousa, since it is already incorporated from the very beginning, so this will now prevent the precipitation of your black deposits, or the formation rather of your black precipitates. Okay, so what are the uses of your Heidenhain-Sousa in the laboratory? So this is utilized for tumor biopsies, especially of the skin. Okay, so skin tumor biopsies. Okay, and then the last mercury chloride-based fixative is your B5 fixative. So do not forget B5. This is used for B as in bone marrow biopsies. Okay, so BBB. So B5 bone marrow biopsies. This is oftentimes asked in the board exam. Actually, it has been asked several times in the board exam. So do not forget your B5 for bone marrow biopsies. Okay, so those are the different mercury chloride-based fixatives that we can use in the laboratory. All right, so now let us move on to the different chromate fixatives. So again, for your chromate fixatives, we only have 4 also. And how are you going to know that it contains chromates? Very easy. Chrome, di ba? Chromic acid, potassium dichromate. So the only other 2 formulations in which you don't have a clue is, or are rather, your regauds and your orts. Okay, so regauds and orts, they are also considered to be chromate fixatives. Okay, so what are the uses, or yes, what are the uses of your chromate fixatives in histopath? So chromic acid, this is utilized for the preservation of your carbohydrate. So that means it can be used as a histochemical stain. Okay, so another, we have your potassium dichromate. So potassium dichromate, this is utilized for the fixation of lipids as well as mitochondria. Okay, so I repeat, it allows the fixation of lipids and your mitochondria. Okay. So however, the use of your potassium dichromates, it actually depends upon the pH of your potassium dichromate solution. Normally, the pH of potassium dichromate that we use in the laboratory is 4.5. Okay, 4.5 to 5.2. That's the normal pH, or that's the usual pH of potassium dichromate solution that we use in histopath. All right, and at this particular pH, it is capable of fixing your lipids and your mitochondria. Okay, however, there are instances wherein your potassium dichromate, so this can be acidified. Okay, so I repeat, there are instances wherein your potassium dichromate is acidified in the laboratory. And just like what we have learned in the discussion, in our discussion for your nuclear and your cytoplasmic fixatives, okay? So when a particular solution is acidified, okay, so below 4.5 in this case for your potassium dichromate, it can no longer fix your cytoplasmic structures. Tama ba? Okay. So that means acidified potassium dichromate, it has a different use in the laboratory. So if, for example, you make use of your acidified potassium dichromate in the laboratory, so instead of using it to preserve your mitochondria, because at this pH, talagang masisira si mitochondria, based on our discussion on your nuclear and your cytoplasmic fixatives. Okay? So ano ma'am ang na-fix? Pag inacidify natin, if we acidify your potassium dichromate. So acidified potassium dichromate is capable of fixing your chromatin fibers and your chromosomes. Okay, so it is able to preserve or fix your chromatin and your chromosomes. Okay, so again, the disadvantage of acidifying your potassium dichromate is that you can no longer use it to preserve or to fix your mitochondria. Okay, so another chromate fixative that we can use in the laboratory is your regauds. So again, your regauds is otherwise referred to as your Moller's fixative. Okay, so what are the different uses of your regauds? It is capable of, okay, it is capable of fixing the following structures. We have your chromatin fibers, your mitochondria, your mitotic figures, your Golgi bodies, your RBCs, as well as your colloid-containing tissues. A very good example of a colloid-containing tissue is your thyroid gland. Okay, so if you can still remember your thyroid follicles, diba? Your follicular cells or your thyroid follicles, they contain a colloid substance, which is your thyroglobulin, okay, which is needed for the production of your thyroid hormones. All right, so that is a very good example of a colloid containing tissue. Okay, and then lastly, ito favorite din po nila ito sa board exam. Last chromate fixative is your ORTS. So your ORTS chromate fixative, this is utilized for the preservation of early degenerative processes as well as tissue necrosis. So that means if you want to observe for the progression of your degenerative process, isang fixative, okay, a fixative that you can use in order to examine your degenerative process is your ORTS fluid. So you would be able to observe the early stages of degeneration, and of course, you would be able to observe also the late stages or the latter stages of your degeneration or of the degenerative process, okay? Such as in the case of your tissue necrosis. Kasi pag sinabi nating necrosis, severe na yung degeneration na nangyari doon sa tissue sample natin. Okay? So necrosis oftentimes is a sign of severe degenerative process. As you may have learned in your pathology, right? In your human histology subject. Okay, so another very important po to do not forget because this is oftentimes asked in the board exam. So ORTS fixative is utilized for the preservation of Rickettsia or rickettsial bacteria and other bacterial organisms. Okay, so we have Rickettsia and other bacterial organisms. The fixative that we can use is your ORTS. Okay, ORTS fixative. All right, so those are the different metallic fixatives that we can use in the laboratory, okay, as well as their respective uses, advantages and disadvantages also. Okay, so now let us move on to another group of fixatives which we refer to as your picric acid fixatives. So what is our mnemonics for our picric acid fixatives? We have your PBB. Okay, so we have your PBB. Okay, so we have your picric acid fixatives, Bowen's, and Brazil's alcoholic picroformol solution. All right, so depending upon the specific picric acid fixative that we are referring to, so they have different uses also in the laboratory. So for your Bowen's fixative, so this is utilized for the fixation of embryos and pituitary biopsies. So for your Brazil's alcoholic picroformol, so from the term alcoholic, diba? I have mentioned this, I have emphasized this several times already. So whenever you see an alcoholic based or a fixative that contains alcohol, pang carbohydrate talaga yan. Okay? And again, of course, the storage form of carbohydrates in humans is your glycogen. So this is otherwise referred to as your animal starch, if you can still remember from your biochemistry, right? Yan. So we are usually after the preservation of your glycogen because yan naman talaga, that is really the predominant form of carbohydrate that is present in tissues because it is the storage form of your tissues. All right, so yan. So those are your picric acid fixatives. Okay, so do not forget our mnemonics. We have PBB. Okay, so we have our PBB. All right, next we have your glacial acetic acid. Okay, so your glacial acetic acid, this is not utilized as a simple solution. So that means it is always, okay, it is always in conjunction or it is always incorporated in the fixative formulations that we have in histopath. hindi ka makakakita ng solution na glacial acetic acid lang for fixation. Okay? So it is used in conjunction with other solutions to make your compound fixatives. All right? So in particular, your glacial acetic acid, again, this is of course, common in your nuclear fixatives. Okay? So this is because of its ability to fix your nucleoproteins. Okay? So I repeat, it is utilized for the fixation of your nucleoproteins. Okay? So the problem with your glacial acetic acid is that it can cause swelling, especially if the tissue sample contains a lot of collagen fibers. Okay, so I repeat, your glacial acetic acid, it causes tissue swelling, particularly of tissues containing collagen fibers. Okay, another characteristic of your glacial acetic acid is that it solidifies at 17 degrees Celsius. So if you can still remember from, I'm not sure if this is being discussed in your lower chemistries, pero your glacial acetic acid, this is actually the most concentrated form of acetic acid that we have in the laboratory. Okay, yan. So concentrated that it is capable of solidifying at high temperatures. Diba? Usually solidification happens at very, very low temperatures. Just like, for example, in the case of water, water solidifies at 0. But for your glacial acetic acid, siguro pag, if you have it here in Baguio City, so it will not exist in its liquid form unless you maintain the temperature to be higher than 17 degrees Celsius. So if during December time or January time here in Baguio, your glacial acetic acid will really solidify. Okay, so it solidifies at 17 degrees Celsius. Okay? Yan. And of course, the next group of fixatives that I will be discussing, we have your alcohol fixatives. Okay? So for your alcohol-based fixatives, they are oftentimes utilized as simple formulations. Okay? Simple formulations. So that means you just dilute them to a particular concentration and that's it. You can use them already for fixation. Okay? So your alcohol fixatives, again, they are utilized in the laboratory for the fixation of your carbohydrates. Okay. However, take note that your alcohol fixatives, they are contraindicated in the fixation of fats and lipids. Why? Because, again, your alcohol, it is an organic solvent. So that means it is capable of dissolving out your fats and lipids. Okay, so as a general rule, the use of your alcohol fixatives is contraindicated in your fats and lipids, but not in your carbohydrates. Kasi pang carbohydrate talaga sila. Remember, what is our rule in carbohydrates again? Do not use aqueous solutions because your carbohydrates, particularly your glycogen, is soluble in your water, okay, or in your aqueous solutions. All right, so what are the different alcohol fixatives that we can use in the laboratory? So we can make use of 95% ethanol. In some other references, it is 70 to 100% ethanol. So your ethanol, this is utilized as a simple fixative. And do not forget that your ethanol, it preserves, but it does not fix. Okay? It preserves, ang gulo, di ba? It preserves, but it does not fix your glycogen granules. Okay? So actually, if you are going to read the explanation provided by Gregorius, ibig sabihin, your glycogen granules or your glycogen rather itself is preserved. However, the architectural pattern of your glycogen in your cells, yun ang hindi na pre-preserve. That is the one that is not preserved. It's the architectural pattern. So that's why Gregorius mentioned that your glycogen, it is preserved, but it is not fixed. Okay, so this is because with the use of your ethanol, okay, with the use of your ethanol, your glycogen granules, so they undergo a process which we refer to as your polarization. So when we say polarization, so this involves the movement of your glycogen granules to the poles of your cell. Okay, so your glycogen moves to the poles of your cell. So that's why this process is referred to as your polarization. So that means, okay, again, what are the two important things that we have to consider in the preservation of your tissue samples? Number one is, are we able to preserve the morphology? Okay, so yun ang una mong tatanungin, right? So yes, kung morphology ang pag-uusapan, yes, we are able to preserve the morphology or the structure itself. So the answer to this is yes, okay? With the use of your ethanol in glycogen. So yes, we are able to preserve the morphology, but if we are going to look at the architectural pattern, okay, so that means the location or the arrangement of your glycogen in your cells, then the answer to this is no. Okay, so we are not able to preserve the architectural pattern of your glycogen granules in your cell because they undergo the process of polarization, which involves the movement of your glycogen granules to the poles of your cell. Okay? So another alcohol fixative that we can use in the laboratory is your 100% methanol. So your 100% methanol kasi this is considered to be a toxic, okay, a toxic substance in the laboratory. So that's why we are limiting the use of 100% ethanol. Okay, but in the laboratory, your 100% methanol, this is oftentimes used for your dry and your wet smears, as well as for the fixation of your blood and bone marrow smears. Okay, so blood and bone marrow smears. Okay. Another formulation that we can use, we have your 95% isopropyl alcohol. So your 95% isopropyl alcohol, this is utilized for your touch, for the, fixation of your touch prep. Okay, touch prep. Ayan. All right. And another alcohol fixative, we have your carnoise. Carnoise, this is considered to be the most rapid fixative, okay? And it is utilized for the fixation of the following. We have your chromosomes, lymph glands, and urgent biopsies. So since it is utilized or it is considered to be a rapid fixative, so it is also utilized for brain fixation for rabies diagnosis. Okay, so brain fixation for rabies diagnosis. All right, so may I just add, your carnoise fluid, it is also utilized for the fixation of Nissl and, I hope you can still remember Nissl. Nissl and other cytoplasmic granules. Okay, can you still remember the structure Nissl granules? Diba, they are the ones responsible for the basophilic character, or they cause they cause basophilia in your neurons. Okay, so they appear as basophilic structures in your neurons. If I remember it right, it's an aggregation of a particular organelle. Kaya ganun. Okay, so we have your Nissl granules. Alright, ayan. So for your carnoise. Okay, so another and the last one, second to the last. So we have your newcomers. So your newcomers fluid, this is utilized for the demonstration or the or the fixation of mucopolysaccharides and your nuclear proteins. Okay? So again, in addition to all of this, do not forget your GENDRAS fluid or your alcoholic formalin, which is utilized for the fixation of sputum samples. Okay? Yan. So those are the different alcohol fixatives that we use in the laboratory. Okay? Yes, and then the next group, we have your osmium tetroxide. Actually, for osmium tetroxide, you don't have to memorize a lot of things because parehas na Flemings ang pangalan ng formulation. Okay, so both formulations have the same name. Okay, they only differ in the presence or absence of your acetic acid. Okay, so the first formulation, we have your Flemings with acetic acid. So again, your clue here is that it contains acetic acid. And so, they are recommended, or this is recommended for the fixation of your nuclear structures. Okay? Yes. Your Flemings with acetic acid, this is actually considered to be the most common osmium acetic acid solution. Alright, so most common chrome osmium acetic acid formulation. So from the term itself, it contains chromate or chromic acid. It contains osmium tetroxide or osmic acid, and it contains acetic acid. Okay, so tatlong acids ang meron. Si Flemings with acetic acid, chromic acid, osmic acid, and your acetic acid. Okay. Flemings without acetic acid on the other hand, so this is utilized for cytoplasmic structures. Again, your clue here is the absence of your acetic acid. So remember that your acetic acid, this is a common component of your nuclear fixatives. And of course, its absence indicates that the fixative is a cytoplasmic fixative. Okay, so what are the two acids, therefore, that are present in your Flemings without acetic acid? We have your chromic acid and your osmic acid. Okay, so your osmium tetroxide, otherwise referred to as your osmic acid, is utilized for electron microscopy. And just like what we have mentioned before, it is a very expensive reagent. And so we only use it, or we only make use of small volumes of osmium tetroxide for fixation. So the recommended volume for the recommended volume of osmium tetroxide for fixation is 5 to 10 times. 5 to 10 times the volume of your fixative. Okay, so other fixatives that we use in the laboratory, we have your trichloroacetic acid. So again, your trichloroacetic acid, this is weak acid that is utilized for fixation and decalcification. Okay, and apart from that, common kasi guys na, or classes pala, a common nature or characteristic of your decalcifying agents is that they are capable also of softening your tissue sample. Okay? So, since your trichloroacetic acid is also a decalcifying agent, ginagamit siya for hard tissue samples. Okay? So when we say hard, not necessarily na bone or teeth hard na tissue sample. Okay? So the hardness or the, diba, the tensile strength, if you can still remember from your human histology, the tensile strength of a particular organism, of a particular structure or tissue, this is dependent upon the presence of your dense fibers. Okay, and in particular, we are talking about your collagen fibers. Okay, so the presence of dense collagen fibers in your tissues, this will make the tissues hard. Okay, and so in order to soften in order to soften, kasi hindi naman pwedeng sobrang hard yung tissue sample natin. Okay? So, this will make it hard, or this will make it difficult for your fixative to penetrate the entire tissue sample. And so, there should be softening. Dapat medyo i-soften mo siya. Okay? And again, for your trichloroacetic acid, the reason why we use it for dense fibrous tissues is that it allows the softening, kumbaga, of your tissue samples. Okay? Ayan, baka malito na kayo, ha? Kasi mama, akala ko ba pag fixation, dapat i-harden. Pero nga kasi, yung dense fibrous, okay, yung dense fibrous tissue, normally na silang mas matigas as compared to the other tissues that we have. Okay? So in this case, it's not a matter of protecting your tissue anymore. Kasi hard na siya eh. Diba? Okay? It's a matter of being able to penetrate your tissue. Yun na yung concern natin. That is our concern already. Not the hardness or not the protection of your tissue, because it is inherently hard. Okay? And so, if it is inherently hard, what do? You have to soften it so that the fixative, okay, the fixative will be able to penetrate your tissue sample. So, that is the case when we are trying to fix your dense fibrous tissues. Okay? Yan. So please do not be confused. Okay? So we are considering here your dense fibrous tissues only. All right? Ayan. So another type of fixative that we can use in the laboratory is your acetone. So your acetone, just like your car noise fixative, it is also utilized for brain samples for the diagnosis of rabies. And apart from that, your acetone, this allows the fixation of water diffusible enzymes. So what are the different water diffusible enzymes which are fixed by acetone? We have your phosphatases, okay? We have your phosphatases and your lipases, okay? So we have your phosphatases and your lipases, okay? So your acetone, this is utilized at very low temperatures. So in particular, we utilize it at -5 to 4 degrees Celsius. So bakit kaya? Okay, why do we have to utilize it at lower temperatures? This has something to do with the volatility of your acetone. Remember that volatility of your substances increases with increased temperature. Okay, so it will, pag volatile, okay, pag nag-evaporate, tama? Kasi volatile substances, they are capable of evaporating at low temperatures, right? Yes. Low temperatures na ang room temperature because volatilization of your substances or evaporation of your substances should happen at higher temperatures. Like for example, in the case of water, water evaporates at 100 degrees Celsius, right? Okay. And so, yung room temperature, low temperature na yon if we are going to consider the evaporation of your substances. Okay? So your acetone, since it is a very volatile substance, how are you going to maintain it at a liquid state if you are going to make use of your acetone at room temperature, for example? Okay? Maaksaya na siya because say for example, you make use of 1 liter at the start of fixation. Later on, your 1 liter acetone that will already evaporate, and perhaps it will become 500 ml na lang after 1 hour, for example. Okay, so in order to prevent the volatilization of your acetone, you have to use it at very low temperature. So in particular, we have -5 to 4 degrees Celsius. Okay? Alright, so let's continue our discussion. Parang di ako nawala, no? Pero nawala ako saglit. Okay. Yes, so let us now move on to the different. So those are the fixatives that we can use in the laboratory. Now, after performing the process of fixation, what are the different steps or intermediate steps that you have to perform before you eventually go to your dehydration or decalcification if you are going to decalcify first your sample. Okay, so the next type or the next step of fixing or the next step, yes, the next step after fixation is number one, we have secondary fixation. Okay, secondary fixation, this is not entirely performed, or it is not routinely performed. Okay, so it is only performed in certain samples that we perform or that we fix in the laboratory. Okay, so that means after fixation, you can skip secondary fixation. If, for example, your your tissue specimen does not require secondary fixation. Okay, but for example, you are going to perform it after the initial fixation. So what does secondary fixation mean? So when we say secondary fixation, it involves, okay, fixing a pre-fixed sample and then immersing it in a second fixative. Okay, so I repeat, it involves fixing a pre-fixed tissue sample using a second fixative. Okay, so what are the purposes of secondary fixation? So number one, okay, secondary fixation is performed in order to improve the demonstration or the fixation of certain substances. So this is commonly performed, okay, in the case of your electron microscopy. So remember that in electron microscopy, we perform a procedure which is referred to as double fixation. Okay, so in double fixation, you are using a fixative, okay, one fixative for the initial fixation of your sample, and then you are going to fix it again in another fixative. Okay, so that is what we call double fixation, and it is an example of secondary fixation. So what is the purpose of double fixation? The purpose is to improve the demonstration or improve the fixation of certain substances. Okay, so remember that in electron microscopy, we are after the fixation of very small details. Okay, so that's why we have to perform fixation twice. All right, so another is to improve staining characteristic. So in particular, this type of secondary fixation is referred to as post-mordanting. Okay, so this specific type of secondary fixation is referred to as your post-mordanting. Okay, so when we say mordant, the term mordant, it refers to a substance which will facilitate the staining procedure later on. Remember that the fixation process, it has to be compatible with the staining technique that you are going to use later on. So in order to promote or to enhance the compatibility of your fixation procedure to that of your staining technique, you can perform secondary fixation. In particular, we call this secondary fixation as post-mordanting. Okay, so it will improve the staining characteristic of your tissue sample. Okay, and then a specific type of post-mordanting is referred to as your post-chromatization. Okay. Yes, a specific type of post-mordanting is referred to as your post-chromatization. All right? So it has the same purpose as that of your post-mordanting kasi nga under siya ng post-mordanting. Right? So if, for example, the substance that is used to improve the staining characteristic of your tissue sample is 2.5 to 3% potassium dichromate, then that specific post-mordanting procedure that you are performing is referred to as post-chromatization. Okay, so what is again the purpose of post-chromatization? It is to improve the staining characteristic of your tissue sample. Okay, so these are the different secondary fixation techniques or procedures that we can perform after your initial fixation. Okay, so after the fixation process, the entire fixation process, so you are already ready to move on to the next step in your tissue processing. So before you move to the next step, in tissue processing, okay, so of course we have our post-fixation treatment procedures, okay? Diba we have our post-decalcification treatment procedures, right? So it's the same thing. After fixation, we have what we call post-fixation, uh, post-fixation, tama. Post-fixation treatment procedures. Okay, so post-fixation procedures includes washing out. Actually, yan lang naman ang post-fixation treatment na this is the only post-fixation treatment that we perform after fixation, and that is washing out. Okay, so when we say washing out, there are two purposes of washing out. Nasa, ano niyo din? Wait lang, class ha. Titignan ko lang. Wali. Alright, so there are two purposes of washing out. Okay. Washing out, andito pala, to remove excess fixative, and washing out to remove pigments which may have formed, okay, in your tissue sample. Alright. So removal of your excess fixative, this is very important in order to prevent, okay, in order to prevent prolonged contact between your fixative and of course your tissue sample. Okay, so how do we remove excess fixative from our tissue samples? We make use of three solutions only. Okay, so we have tap water, we have 50 to 70% alcohol, and we have your alcoholic iodine. Okay, so tap water, this is utilized for the removal of chromates, formalin, and osmic acids. Okay? Yes, so tap water removes excess chromates, formalin, and osmic acid. Okay? So for your 50 to 70% alcohol, on the other hand, so this removes excess picric acid. Okay? So this removes excess picric acid. So actually, in the removal of your picric acid, do not use water because it will entirely remove the picric acid. So what we are trying to remove here is just the excess fixative. Okay, so do not forget that what we are trying to remove is the excess fixative only, not the entire fixative. Okay, ayan. So 50 to 70% alcohol for your picric acid. Your picric acid kasi it is very water, it is water soluble. So you don't want to remove picric acid that is not in excess. Okay, and then the last one, we have your alcoholic iodine. So your alcoholic iodine removes excess mercury chloride fixatives. Okay, so mercury fixatives or mercury chloride fixatives. So the other purpose of washing out is for the removal of pigments. Okay, so what are the different pigments which you have to remove from your tissue sample? All right, so first let us discuss the formalin pigments. So actually, for your formalin pigments, I have mentioned them in our discussion, in our previous discussions. So what formalin pigment or precipitate may form in your tissues. The first one is your paraformaldehyde. So your paraformaldehyde, this is a white precipitate, if you can still remember, right? So that is a white precipitate that that is formed due to the storage of your formalin solution in low temperatures, right? In prolonged storage, rather, of your formalin solution at low, especially at low temperatures. Okay, so how can you remove your paraformaldehyde, which appears as white precipitates? You can perform filtration technique. So this is a physical way of removing your paraformaldehyde. And then of course, you can add 10% methanol. Okay, addition of 10% methanol, this can also serve as a preservation technique. So that means it will prevent the formation of your paraformaldehyde, as well as it is also capable of removing paraformaldehyde that is already present in your solution. Okay, the other precipitate, we have your brown-black precipitate, right? So you're still familiar with your brown-black precipitate, polarizable. Okay, brown-black precipitates or deposits. So this is your heme, okay? Formalin heme pigments, if you can still remember, right? So we have your formalin heme pigments, okay? Formalin, saan na ba yun? Yes, formalin heme pigments. Okay, so which forms in the presence of an acidic environment, okay, during fixation. So your formalin heme pigments, so they appear as brown-black polarizable deposits. So this can be removed with the use of your alkaline picrates. So alkaline picrates, so this is picric acid with 95% ethyl alcohol. So another, you can also make use of 1% potassium hydroxide in 80% alcohol. Okay, so for the removal of pigments also, you can make use of Kardasevich solution and your Lily's solution. Okay, yan. So those are the different, reagents that we can use for the removal of your formalin pigments and precipitates. Okay, so next we have your picric acid. So for your picric acid, we make use of saturated lithium bicarbonate in 70% ethyl alcohol. 70% ethyl alcohol, or you can also immerse it in 70% ethyl alcohol, and then after that, you can make use of 5% sodium thiosulfate. So in addition to these two solutions, you can also make use of Lenoir solutions, which is composed of concentrated ammonium acetate and then 95% ethyl alcohol and distilled water. Right? And then for our mercury fixative, these are the different solutions that we can use. We have your 0.5% iodine solution in 70% alcohol. This is your alcoholic iodine. You can also decolorize it using 5% sodium sulfate. And of course, you can also make use of Langeron's iodine, which is composed of iodine crystals plus potassium iodide. And then, of course, we have your distilled water as the solvent. Okay? So for the presence naman of melanin, so we can remove it using a series of steps, okay, which involves the use of several reagents. So to decolorize melanin, you can make use of potassium permanganate. To reduce melanin, we can make use of your pyrogallic acid. And for the final removal of your melanin, you can make use of hydrogen peroxide. Okay, so other solutions that you can use for the removal of your pigments, we have your for your carnoise rather. So carnoise, the pigments which may be caused by carnoise fluid is removed using your 100% alcohol. Okay, so other types of fixation, actually we have discussed this already. So we have for electron microscopy, ano yung ginagamit natin na procedure? We have your double fixation. Okay, so double fixation, this involves the use of your aldehyde fixatives, and then after which you make use of your osmium tetroxide. So aldehyde fixatives for electron microscopy includes your Karnowski and your acrolane. Okay, so remember that our goal in performing double fixation is to preserve the different minute details which are present in your cells and your tissues. Okay, so after aldehyde fixation, the second fixative that we use is buffered osmium tetroxide. Okay, yan. Buffered osmium tetroxide. So the pH of both your aldehyde fixatives and your osmium tetroxide is between 7.2 to 7.4. So what temperature again do we perform? In what temperature do we perform the fixation process for electron microscopy? Ano ang ating temperature? We have 0 to 4 degrees Celsius. Okay, for electron microscopy. So specific osmic acid fixatives that we can use. We have your Palids fixative, we have your Ceterkist osmium fixative, and your Melonids osmium tetroxides. Alright? Yeah, sa exam hindi ko to. Ba't mo ba sinabi? Wala, bakit? Okay. Hindi, basta ang, ang alam nyo lang dapat for electron microscopy, we make use of an aldehyde and then your osmium tetroxide. Okay? Malay ko kung may gustong mag-memorize ng mga yan. Okay? So, ayan po. And then, for enzyme histochemistry, so we can make use of 4% formaldehyde or formol saline. And then, for frozen sections, we have your acetone or formaldehyde. Okay? Fixatives naman for smears, we have your iodines, ether alcohol, methanol. So, this will be elaborated later when we go to your exfoliative cytology. This one naman will be elaborated when we go to your special techniques. Alright, so other methods, we can make use also of heat. We can also make use of microwave fixation, which involves the use of vacuum heat and agitation, as well as, of course, your formaldehyde fixatives. Okay, so for the special techniques, sige, discuss na natin. So special techniques, this involves the use of rapid freezing, otherwise referred to as quenching. Okay, so since there is the need for you to perform rapid freezing, so you have to make use of your freezing agents. So the most common, okay, the most common and the most rapid freezing agent that we have in histopath is your liquid nitrogen. Okay, so when do we perform your special techniques? We perform it if, for example, chemical fixation is to be avoided. Okay, why? Because, like for example, in the case of your enzymes, chemical fixation may lead to a partial loss of your enzymes. Okay, so special techniques, it is particularly useful for histochemical studies. Okay, for histochemical studies. All right. So again, why do we need to rapidly freeze your tissue samples? So this is in order to prevent the production of large ice crystal artifacts. Okay, ayan. So liquid nitrogen, this is particularly useful for histochemistry and for intraoperative procedures. So when we say intraoperative procedures, there are certain instances wherein the surgeon would like to consult the pathologist ASAP or immediately or during the surgery. Okay? So if that is the case, you have to make use of rapid techniques. And one of the most common rapid techniques that we that we perform in the laboratory involves the use of your liquid nitrogen because again, it is the most rapid freezing agent. Okay, ayan. So other freezing agents that can be used, we have your isopentane, pentane, propane, dichloro, difluoromethane, your aerosol sprays, and of course, we have your carbon dioxides. Okay, your carbon dioxides, maraming carbon dioxide. All right. So the two special techniques, we have your freeze drying and then the other one is your freeze substitution. Okay. So freeze drying, this involves rapid freezing of your sample. So there is actually a a required thickness of your sample. So the required thickness is 2 millimeters thick. Okay, so after you have this tissue sample, you have to make use of rapid freezing, or you have to freeze your sample rapidly. Okay, rapid freezing of your 2 millimeter thick tissue sample. So rapid freezing, this is carried out at very low temperatures. Specifically, we have 160 to 180 degrees Celsius. Okay, ayan. So 160 to 180 degrees Celsius. So after rapidly freezing your tissue sample, the next step that we are going to perform is desiccation. So if you can still remember, actually desiccation, this is the drying process. Okay? Diba, desiccation is otherwise referred to as drying. So desiccation or drying, this is via the process of sublimation. Oh, very elementary. Diba, anak ko, alam ang sublimation. So ano ang ibig sabihin ng sublimation from your elementary science class? Sublimation involves the change, okay, in the state of a solid matter. So your solid, this will turn into gas without going through the liquid state. So from solid to gas, okay? Yes, so sublimation, this is usually carried out in a vacuum. Yeah, so of course, the presence of vacuum or negative pressure in your equipment, so this will allow the rapid, okay, the rapid sublimation of your ice crystals or your ice, your ice, yes, your solid to your gas, okay? So, uh, so, uh, desiccation, how long are you going to perform it? You have to perform it for 24 to 48 hours. Okay, so this is performed in a vacuum for 24 to 48 hours. Okay, so after drying or desiccation, the next part is to infiltrate and embed your tissue sample. Okay, so again, for the infiltration and embedding procedure, we make use of a special equipment which we refer to as your vacuum embedding oven. Okay, so we make use of a special equipment, which is your vacuum embedding oven, and the following media may be utilized for infiltration and embedding. We have your molten paraffin, your water-soluble waxes, and your celloidine. Okay, and the last one, we have your freeze substitution. So actually, when we say freeze substitution, it has the same procedures, initial steps, with that of your freeze drying. But since this is substitution, so after freezing, you are going to use your substituting fluids. Okay? Your substituting fluids, ayan, your substituting fluids, they have, or one specific requirement is that they have to be solvents. Dapat solvent ang substituting fluid natin. So that means since you are performing substitution, your free substitution does not involve desiccation or drying. Kasi sa isa yon, di ba? Kaya nga ang tawag natin, that's why the other special technique is freeze drying. So there is desiccation. This one, This is free substitution, so that means no drying, no desiccation. What do you perform? You perform substitution by using your solvents or your fluids. Okay? Yes. So what are the different solvents that you can use? You can make use of your alcohol-based. Okay? You can make use of your alcohol-based solvents like your Rossmann's fluid. Okay, another, you can also make use of your osmic acid in 1% acetone. Okay, yan, osmic acid in 1% acetone. So for the specifically your Rossmann's fluid and your osmic acid in 1% acetone, so they are utilized for the initial fixation of your, or for the fixation of your tissue sample. Okay? So dehydration naman in free substitution, this is accomplished by using absolute alcohol or acetone. Okay? Yes. So what is the basic procedure for your free substitution? Again, you have to rapidly freeze your tissue sample. And then after that, you have to perform. Okay? You have to substitute the frozen water molecules which are present in your sample. So you have to make use of your substituting fluid. Okay, so after your substituting fluid, then you can perform your infiltration and your embedding. Okay, so same lang sila except for the middle step. So in your freeze drying, you have to desiccate. That's why it's referred to as freeze drying. In your freeze substitution, you have to substitute. What are you substituting? The water molecules. What are you drying? The water molecules. All right, so those are the special techniques that we can perform in the laboratory. Okay, in histopath. So this is the end of the video. So again, if you have questions, don't forget to raise it via our group chat. All right, I'll see you again next time.